But I kind of became interested because I will not read this poem. I will just like have it here a little bit because it's a very nice poem, fitting for the. Yes, I came upon this gathering, this symposium that you have organized, and I felt it was. I just felt it was really important for my research to be there because it's kind of dealing with questions that I'm exploring, but a decade later in the 70s, and as I've been listening in to the discussions, it's become more and more clear how important it is for the discussions I'm doing, like in the 70s, and I'm already seeing now it might take some. Perhaps it will have some impact on my research. I have been digging into some things, and I will discuss it a little bit today about the brain in Delos that I will talk a little bit about. But I will not talk about design thinking because as I wrote my paper, things kind of happened, and it became something else. But let's start with the island. The ancient ruins, the moon-like landscape, the island of human unsettlements, where in July 1963, Buckminster Fuller spoke about the future of humankind. Standing in the midst of the ancient theater of Delos, his voice loudly transmitted across the acoustic space. I believe that our voice here, he said, to the small crowd, will be heard all around the world, and that it will catalyze the efforts to prevent man from eliminating himself from his extraordinary role in the universe. Quote end. His words spoken at the first Delos symposium open up two crucial points. First, his statement bear witness to a time of tension, as we have discussed today, of novel uncertainty. Second, his reflection raises the question of the status of human beings, as Simon also talked about. In this time of transition, we face ourselves as the enemy, he said. We are in danger of destroying ourselves. And what I find especially remarkable about the Delos Symposium is the similarities of the ideological, critical, and conceptual debates taking place in the field of architecture and urbanism in the 1960s to the ideological, critical, and conceptual landscape of ideas of today. 50 years ago, the network emerged as a model for conceptualizing reality, a model that is still operational today. 50 years ago, the possibilities of ecological catastrophe developed into a new danger, and the environment suddenly became something we have to protect, a condition which has only intensified in our era. 50 years ago, developments associated with the digital revolution permitted visions of the computer as an inanimate, quasi-human thing, thus posing new questions about the value of human life, issues that are even more pressing today. At the Delos Symposium, an interdisciplinary group of scientists and intellectuals were searching for new methods to comprehend the new situation. Today, we still search for those methods. We still search for a solution. And in this talk, I will make some overall remarks about the ideological landscape and conceptual orientation that vibrantly came to the fore in the Delos Symposium. I will first address the interdependency of ecology and cybernetics as a conceptual underpinning of the symposium. And I will exemplify this underpinning by discussing how the brain was understood by the Delians as a recurring metaphor for the planetary city. And I will finally discuss how the conceptual landscape of the Delos network took part in an epistemological shift that still echoes today in recent discourses related to the Anthropocene and to which the discursive discussions at the symposium laid critical foundations. When Siegfried Gideon opened his paper at the first Delos Symposium with locating the danger of our age in a notion of complexity of problems, it must have sounded like a familiar concern to the crowd of scholars. In Architecture in Transition, which was published in 1963, Doxiadis introduces this analysis with establishing that the present time is an age of confusion, because the world as a whole was now venturing into an era governed by a new kind of uncertainty. There was something taking place, something that was not yet intelligible. An old system of thought was on the way out, but a new one was not yet there. And the argument of Doxiadis' book was that 5 problems: population growth, economic development, socialization, urbanization, and industrialization and technological progress were fully entangled and depended on each other, so no single architectural action addressing 1 or 2 of the factors could have any effect on the whole. The problems depended on each other and reinforced each other, and this extending entanglement was a precondition for their emergence. In the words of Doxiadis, a coexistence of many forces, a dynamic situation which creates a host of problems for every aspect of our lives. Interestingly, in Architecture in Transition, Doxiadis questioned if the current scientific discourse were fostering conceptual notions of stability and linear causality, and thereby directing attention away from the actual challenges. Dynamic problems needed dynamic solutions. Since the planetary problems were all interrelated, the solution had to be one dynamic synthesis. And Doxiadis found this new synthesis in cybernetic theory. And in the end of Architecture in Transition, he affirmed that cybernetics and other new theories will gradually facilitate our better understanding of the complex problems we are facing. And with the establishment of acoustics, Doxiadis indeed built a new science, to some extent, quite maybe to a far extent, based on cybernetic theory that could comprehend and synthesize complex notions such as instability, rapid changes, and non-linear causality in relation to the totality of human settlements, as we have heard today. So, when asked what is cybernetics in a TV interview in the program High Tech Heroes, which is a great series of YouTube videos that you can watch, one of the key figures within cybernetics, Heinz von Forster, answered, "It is happening right now. By having a dialogue, cybernetics exists," before pronouncing that cybernetics could not really be defined. When the TV host got impatient and wanted the researcher to give him a clearer answer, von Forster pointed towards an image he had brought to the show. The image shows an Ouroboros, an ancient symbol of either 1 or 2 dragons or serpents eating their own tail. Ouroboros is Greek for the one who eats its own tail. And the symbol occurs in mythologies around the world, from Indian thought to Norse mythology, and gives form to that which unifies the whole. And the Ouroboros eats its tail to sustain life. Life feeds on itself. And by its very nature, cybernetic thinking is biological. The transdisciplinary and highly diverse field of research can be defined as the science of complex systems and control of these systems. Early cybernetic approaches originated in the 1940s as a framework for understanding, control, and communication within animate and inanimate realms. The field of research is highly connected to the biosemiotics of Jakob von Uexküll, and in the 1950s and 1960s, cybernetics came to be connected to general currents in the humanities. And yet, despite the field of study's diversity, the development of advanced machine technology had a prominent position in development of cybernetics, as we heard in Janus's talk. New and exceedingly complex technical advances required a new set of theories to comprehend these innovations, yet perhaps surprisingly, it was within nature itself, within life, that mathematicians and early computer theorists found a mode of thinking applicable to the new set of technologies. Hence, another scientific field intimately related to the development of cybernetics is ecology. We have discussed quite thoroughly today, but I will still make some general remarks because it will be important from argument in the end. In short, as scientific inquiry progressively broke the world down to smaller fragments into the 18th and 19th centuries, disciplines became ever more specialized, and to grasp a sort of conception of the whole seemed more and more problematic. In modern ecology originates in the field of biology in the latter part of the 19th century, with Ernest Haeckel often being mentioned as a key influence. And the apparatus offered an intrinsic holistic method of study which enabled interdisciplinary approaches to the object of study, which was the interrelation between an organism and its environment. Importantly, ecological theory states that an ecosystem cannot be predicted or understood by a simple summation of its parts. Ecological studies are necessarily holistic as opposed to reductionistic, and the same applies to systems theory. And as cybernetic thinking and advanced machine technology progressed in the 1950s and 60s, the idea of the machine as defined by what it can do transformed into understanding machine technology as a real-life organism. The development of more complex computers gave rise to a mode of thought that departed from previous system thinking. And briefly stated, pre-computer machine technology has a less complex response system. The machines respond in a direct line to singular commands and just perform the commands given. However, linear causality and singular response system could not account for how a complex computer operated. Embedded in the technical specifications of a complex computer is a notion of non-singular and non-linear causality. And following this technical development, the field of cybernetics developed into a second wave of cybernetics called second-order cybernetics in the 1970s, whereas the first generation of cybernetics provided a mode of thinking closed systems, that is, feedback loops of inputs and outputs. Second-order cybernetics understood the cybernetic mode of thinking as providing a theoretical framework for adaptive and responsive, open-ended environments where the observer was a part of the overall system. In early cybernetic theory, the system was being steered. And in second-order cybernetic theory, the system itself was understood as the governing force. Thus, the system allows action to happen or not to happen, and not singular commands. And this change can be exemplified by two different versions of von Forster's Ouroboros. Because in the TV program, von Forster showed one circle of creatures feeding on its own life. When the journal Cybernetics and Human Knowing dedicated a special issue to von Forster, the year of his death, the Ouroboros is circled by another Ouroboros. The holistic system had grown to include all there is. That is why von Forster answered, "It is happening right now," when asked to define cybernetics. Second-order cybernetics offered a mode of thought that destabilized individual agency of the observer and includes him or her in the overall system. It facilitated equilibrium between all entities in an open-ended system. And in a much-cited 1977 article in Science called "The Emergence of Ecology as a New Integrative Discipline," renowned biologist Eugene Odom stated that we scientists are ignorant of the ecosystems of which we are dependent parts. As a result, today we have only half a science of men. In this article, Odom observed that the field of ecology had evolved into a new integrative discipline comprising psychology, sociology, political science, the arts, public environmentalism, and public urban planning. Odom differentiated between the initial biological form of ecology and the new ecology by defining that the status of the observer seemed to have been altered. In the new ecology, a researcher was also a part of the system being observed. This insight must have sounded rather familiar to Doxiadis and the other Delians, who already in the early 1960s operated with an open-ended logic of a system, in the sense that both the system, the city, and the observer, the human, was understood to be responsive and adaptive to changes in the overall system. At the first Delos symposium, the ecological or cybernetic conceptual underpinning clearly was second order or new, considering that this is one of this kind of quotes that we don't know who said, but the group repeatedly stated the imperative need for open-ended planning, flexible enough to respond to unforeseen changes. This is from 1963. 15 years after the first cruise to Delos, the field of ecology finally caught up with pioneering ecological advances in the field of architecture. This reconception of the relationship between an entity and its environment, that is the shift from orthodox ecology to new ecology, or cybernetics to second-order cybernetics, is especially vibrant in the Delian understanding of the brain. Okay. Electronic technology has extended the brain itself to embrace the globe. Marshall McLuhan stated at the first Delos Symposium in 1963. And in an effort to explain and validate his notion of the planetary city as network, Doxiadid pointed towards a biological logic of neurons in opposition to the centralized logic of a tree. He wrote, We can then remember how the neurons are interconnected in our brain. They do not form any trees, they simply have some connections which are stronger than others. And in his book, The Cybernetic Brain, Andrew Pickering shows how development in brain research in the 1950s onward contributed to this new understanding of the machine as a living entity. In the cybernetic understanding, the mechanisms of the human brain were not static, but rather adaptive maneuvers in response to the surrounding conditions. As Pickering explains, the cybernetic brain was not representational but performative, and its role in performance was adaptation. The cybernetic understanding of the human brain evolved in accordance with development in advanced computer technology, and Pickering's investigation shows how biological mechanisms and advanced computer technology mutually influenced each other's theoretical developments. And the brain figured prominently in Kenzo Tange's contribution to the symposium. A long quote, sorry. In large contemporary urban complexes, communication networks twist and intertwine into complex which must be something like the nervous system of the brain. Large metropolitan areas or megalopolises in our day are becoming brains for the body of modern society. Whirling around in these brains are the people and the information. The citizens are like electrons flowing in an electronic brain. And Doxiadis also talks about more about the brain, but I'm not going to introduce. I have gone through the acoustics and located all the discussions of the brain, which is quite interesting. But Andrew Pickering's key argument is that, I quote him, cybernetic models of the brain and understandings of the self point immediately to a decentering of the mind and the self. Quote end. The brain transgresses its own borders, sprawling away from its neurological center as the computational environment metaphorically, conceptually, and to some extent also materially merged with the biological. The cybernetic brain was performative and adaptive. The inputs and outputs altered according to environmental conditions, which led the cybernetic visionaries to envision the computer as an inanimate, quasi-human thing. The human mind invented the computer as an extension of humanity's integral computer information storing and retrieving system, the brain, as Buckminster Fuller emphasized in his paper, The World Game. The cybernetic synthesis between the biological brain, the technological computer, and the natural environment crystallized in the research of anthropologist Gregory Bateson in the 1950s and 60s. Bateson explored communication information in an extraordinary range of disciplines. His main finding in studying communication systems was that the border between a system and its context was hard to trace. And he developed this into an anthropological theory in close collaboration with Margaret Mead. Human and animal communication was for Mead and Bateson extended, across and within social and cultural contexts as an ecological condition itself. And it was not simply only located in the individual. And this led Bateson to an epistemological theory that the human mind was not located in the brain. Like an ecosystem, Bateson argued, the cognitive mind was extending into the environment. The mind became a network that constantly participated in an open-ended cognitive system. In the computational landscape, conceptual landscape permeating the discursive debates at the Delos Symposium, we clearly see a shift of attention from the system that is to be observed to the system of which we are all a part. Yet importantly, the system of which we are all a part is beyond anyone's control, as Doxiadis affirmed in Architecture in Transition. Notions of hierarchies and control gradually dissolved, and although Doxiadis insisted on his belief in technocratic planning, he still considered the environment as a whole to have profound effect on the individual. And in the book, What Do We Do With Our Brain?, philosopher Catherine Malabou discusses contemporary neurobiology and argues that the understanding of how the brain works projects meaning into a social and political organization. How the brain works scientifically is how the subject works individually, and by that, this is also how society works. Could we say the same about the symbolic understanding of the brain, about the analogy of the brain and the city? The cybernetic brain was working in a constant state of becoming, in a seemingly continuous loop of recurrence with the world. Thus the brain and the world were continuously bound up with each other and thus engaged in a process of coupled becomings. And interestingly, in the Delos Symposium, it seems to be a consensus that a conceptual model of a cybernetic extended brain or an ecological mind indeed projects a structure into society with the same mode of being, the same economy as the analogy. The brain, as understood in cybernetic terms, is a highly flexible and adaptive organ. Just as the structure of the world was considered to be unstable and flexible, so was the logic of the planning scheme, as Panayota Pila eloquently has emphasized. And I quote her, "Ecistics believed that inequality, exclusion, and exploitation in their various forms could somehow be planned away as long as enough flexibility was built into managerial system," quote end. Yet not only the cybernetic brain contributed to a redefinition of the biological self. Equally, our genes came to be infiltrated by the second-order cybernetic environment. Because Conrad Waddington was a leading embryologist and geneticist who attended all 10 Delos symposia. Today, he is considered to be the father of epigenetics. In the 1940s, he formulated a theory about the adaptability of the genome and the importance of environmental feedback or lack thereof in the formation of our genes. Of significance is that Waddington's epigenetics did not consider the environment to be a three-dimensional entity. It even stretched into the fourth. Perhaps that's why Doxiadis, who constantly reminded his audience that settlements was not only three-dimensional but fourth-dimensional because of the time, maybe that's why he was sympathetic to Waddington's systemic biology. According to epigenetic theory, genes are not set in stone, they are malleable, and they absorb the environment in the past, in the present, and in the future. The pioneer of epigenetics even emphasized the kinship between ecistics and epigenetics. In his words, biological organisms have a fundamental quality, which is fundamental in ecistical systems, which might be considered parallel to biological organisms. This property is that of the changing in time. And in the 1990s and 2000s, new discoveries in epigenetics were to far extent confirmed. They confirmed Waddington's theory, which means that your parents' and grandparents' environment has crucial effect on not only your life, but on the life of potential multiple generations. Okay, my last part. Um, any system, whether it is your body or an island on the Earth, must return upon itself. What kind of human subject does acoustics operate with? Paraphrasing Paul Valéry, Doxiadis locates the human subject in its trace. In Doxiadis' words, in living, working, running, walking. The human subject of the Delos symposium, although there was different, of course, different conceptions of this, but a kind of consensus, it seems, that the human subject of the Delos symposium, it seemed to be an unstable subject, always moving, always becoming. I seem to be a verb, as Buckminster Fuller's book from 1968 is called. And the unstable subject co-occurs with a dynamic, even non-existing notion of center. Whenever I draw a circle, I immediately want to step out of it, as it says here. In the early 1960s, Doxiadis envisioned his entopia to be, I quote, a continuous network of centers. In Jacques Derrida's 1966 lecture, Structure, Sign, and Play in the Discourses of the Human Sciences, he introduces his conception of the word play, which became one of Derrida's most notable ideas. In this lecture, Derrida turned the structure that governed epistemological notions in structuralist thinking upside down or inside out. Structuralism aimed to uncover the structure that permitted epistemological truths to exist as truths, whereas Derrida rendered the uncovering of the structure itself to be impossible. Derrida argues that play, in some sense, is an origin in a structure which has no origin. The structure was unstable. It was even inaccessible. Briefly summarized, Derrida establishes that there is no center or organ in the structure. There is only a trace of play, of movement that never really stabilize. Derrida's lecture on the notion of play is known to mark the onset of post-structuralism. This insight is reflective of contemporary issues in the humanities connected to the theoretical apparatuses such as new materialism and post-humanism, which is bound up in a radically ecologized ontology. There is a conceptual genealogy from today's methodological approaches in environmental humanities aiming to destabilize subjectivity and objectivity as epistemological notions to ecological modes of thinking developed decades ago. Methodological attitudes within fields such as new materialism or post-humanism primarily aim to transcend the familiar epistemological dualisms like culture and nature, subject or object. As John Law and Bruno Latour describes, and I quote, "In this scheme of things, entities have no inherent qualities. Essentialist divisions are thrown out on the bonfire of dualisms. There are no divisions." Quote end. All of these shifts in our contemporary theoretical landscape can undoubtedly be tied to the arrival of the Anthropocene and the decentering of human exceptionalism. And in this way, the questions explored by the Delians is tied to our current climate. Which returns us to Buckminster Fuller's speech in the Theatre of Delos and his call to prevent the breaking of human exceptionalism. Instead of preventing it, the neo-vitalized impulses of the cells and cities of the Delos Symposia accelerated it. When asked about the concept of tragedy in the 1972 Playboy interview, Fuller answered, "If for one instant we could come to understand our universe and could perceive ourselves as one with it, we wouldn't have to consider such a word as tragedy. We would see that there is absolute immortality." In the 1969 Acoustics article, The World Game, he noted, "But I observed that we are functioning in a region of the universe where everything has been made tolerable for our specific technological model of regenerative life to go on." In his attempt to prevent the breaking of human exceptionalism, he dreamt of ultimate vitalism, eternal recurrence of life. Global warming and capitalist globalization have created an environment we cannot change, we cannot escape. In dark times, lighting up the bonfire of binaries will indeed illuminate our surroundings. It will make us see things in a different light. Yet, as with all bonfires, perhaps the illuminating light is bound up to potentially toxic smoke. So in the end, let's return to the island where there is no end. The ancient cultural hub in the midst of the Mediterranean trade route. In his article, Network Fever, Mark Wigley presents the island as a paradoxical site for discussing diagrams of network flows or biological, technological extensions. Wigley writes, I quote him, "To engage with the global networks whose key feature is that no point has any more value than any other. The group disconnected from those networks and returned to a very singular point, the ruins of the mythical source of Western philosophy. Yet the group did not withdraw to a singular island detached from the continuum of connectivity. They did not withdraw to an origin. The Delos Declaration was signed in the place perhaps most fitting of all, the site with no origins and no ends, no births and no deaths. It was a site of perpetual becoming. In Buckminster Fuller's words, the island is a system that must return upon itself, an Ouroboros feeding on its own life. And even the etymology of Delos resists the notion of withdraw, meaning becoming clear or visible, reveal or expose. The island is perhaps the site par excellence of vitalism, a place without mortality, a place for gods. And when the etymological origin of Delos, which is the Indo-European root deo, also gave the Latin Deus, the connection between the island, Doxiadis' Ecumenopolis, McLuhan's extended brain, Waddington's epigenetics, Buckminster Fuller's dream of immortality, and Yuval Harari's popular prophecies of Homo Deus. Perhaps this doesn't seem that paradoxical. Perhaps it's no accident that Delos is the vacation of the future in the sci-fi movie Westworld from 1973. And in the recent HBO remake version, a global corporation selling immortality. Thank you.